Hello, and welcome to a little video for the Unit 4 quiz review. Let's get started. In number 1, I see that we have some multiplication going on. So I'm going to use the product rule, which states that if we're multiplying two of the same base, we can add their exponents. Now we have A and B, so let's add those. A in the first pair has an exponent of 10, and in the second pair, it actually has an invisible exponent of 1. So, to get the exponent for A, we will do 10 plus 1. To get the exponent for B, we're going to add the exponents that it has as well. So the first one has an exponent of 6, and the second has an exponent of 9. Let's add. We get A to the power of 11 and B to the power of 15. In number 2, I see a couple of other things that we didn't see in number 1, such as a power of 0 and negative exponents. When we have negative exponents, what it's telling us is that the base that it's attached to is on the wrong side of the fraction line. So if we have a negative exponent on the top of our fraction line, that means that base and the exponent should be moved to the bottom. When it moves to the bottom, it becomes positive. If we have a negative exponent on the bottom of our fraction line, it means that the base should have been on the top of our fraction line. So we move it to the top and make our exponent positive. The rule of the 0 exponent is that anything you can think of raised to the power of 0 is 1. So, let's start number 2. On the top of the fraction, we have 5 to the power of negative 2. That means we should actually write it on the bottom here as 5 to the positive second. Next, I want to fix my highlighter. There we go. Next, we have x to the power of negative 7 on top, which means I should actually have x to the power of positive 7 on the bottom. Z to the power of 4 is positive, stays on top. Let's look at the bottom of our fraction. The bottom of our fraction has a 2. The 2 has a power of 1. That's positive, so it stays on the bottom of my fraction. Y to the power of 0 is 1. Let's simplify a bit further. Whoops. Let's simplify this a bit further. If it lets me erase, there we go. I meant to select the pencil, not the highlighter. The only thing I can do here is multiply out the numbers. That means I could do 5 to the power of 2 times 2 times 1. 5 to the power of 2 is 25. 25 times 2 is 50. And 50 times 1 is 50. So we get 50. I don't know, did I use the right color? I don't think so. I think I used the blue here. There we go. X to the 7th stays where it's at, and so does z to the 4th. Perfect. Let's take a look at number 3. Ooh, okay. Number 3 is a power to product rule. The power to product rule looks very similar to the distributive property. It's not the distributive property. Don't ever tell a mathematician that. It looks like the distributive because we're going to be multiplying every single power by the power on the outside of the parentheses. Let's do that. Negative 4 times negative 2 gives us positive 8. So we have 4 to the positive 8th. Then we multiply negative 4 times positive 9, which is negative 36. And lastly, we multiply negative 4 by positive 5, and we get negative 20. We can't stop there because 1, we have 4 to the 8th, which we can simplify, and 2, we have some negative exponents that we need to take care of. All right, so because we have negative exponents, I'm going to set this up as a fraction, so it'll be easier kind of to look at. First of all, let's find out what 4 to the power of 8 is. I don't remember off the top of my head. Let me calculate that real quick. I did not bring my answer key with me today. That is a huge number. But 4 to the power of 8 is 8 is a positive exponent. 4 to the power of 8 is 65,536. M has a negative power, which means M really belongs on the bottom with a positive power of 36. N has a negative power, which means N actually belongs on the bottom with a power of positive 20. Perfect. Number 4. Number 4 combines a couple of things. It combines power to product rule and power to quotient rule. So we're going to do the same thing that we did in number 3. We're going to pass out that power of 4 to every single term here. And we're going to multiply every exponent by 4. I do want to write it in. 2 has an exponent of 1, and so does M on the bottom. Let's go. I'm going to multiply every single exponent by 4, and then we'll see if we can reduce from there. Or simplify, sorry. 2 gets a power of 4, because 1 times 4 is 4. M gets a power of 32. 8 times 4 is 32. The letter N gets a power of 20, because that's 5 times 4. On the bottom, M gets a power of 4, because that's 1 times 4. And N also gets a power of 20, because that's 5 times 4. Okay, awesome. We can take this further, because we can use the quotient rule. The quotient rule tells us is if we have the same base on the top and bottom of our fraction, we can reduce it by subtracting those exponents. Let's do it. Oh, excuse me. So 2 to the 4th is just 2 to the 4th. There's nothing we can do with that. For M, we will do 32 minus 4. We always do top exponent minus the bottom exponent. Okay, then we have N. The top exponent is 20, and the bottom exponent is 20. Let's keep going. I can simplify 2 to the 4th. 2 to the power of 4 is 16. Okay. M, 32 minus 4 gives us 28. For N, 20 minus 20 is 0. I can simplify that just a bit further. N to the power of 0 is actually 1. And I can multiply 16 times 1, which is 16. So our final answer is 16m to the power of 28. All right, beautiful. Onwards we go. Number 5. Let's do the power to product rule and pass out that exponent. I am going to write in that 9 has a little 1. I'm going to multiply everything by 2. All right. We get 9 to the 2nd, a to the negative 8th, b to the negative 2nd, and c to the positive 22nd. Perfect. We have some negative exponents, which means we need to bring them to the bottom of a fraction, since they're technically on top of a fraction, because everything can be written as over 1. All right. 9 to the power of 2 is 81, so I'll write that down now to simplify. I'm going to take a to the power of negative 8 and write it on the bottom as a to the power of positive 8. I'm going to take b to the power of negative 2 and rewrite it on the bottom as b to the power of positive 2. C has a positive power, so I am not going to change where it's written. Number 6. The first thing that I see that I can do in number 6 is what we did in number 5, and that's the power to product rule. I'm going to write in those little 1s for 6 and x, so I can pass out that negative 2 exponent. All right. So we get 6 to the power of negative 2, x to the power of negative 2, and y to the power of negative 6 all over xy. What I'm going to do next, I don't like seeing those negative exponents. I'm going to flip them. Let's do it. 6 to the negative 2 belongs on the bottom as 6 to the positive 2. X to the negative 2 belongs on the bottom as x to the positive 2. Y to the negative 6th belongs on the bottom as y to the positive 6th. There's nothing left on top. But really what's left on top is 1 by itself. There's always that invisible 1. And we still have times xy on the bottom. We're going to simplify it just a little bit more. The 1 stays on top as is. 6 to the power of 2 is 36. And now let's add the exponents of similar bases. So I can do x squared times x, which is x to the third, because x has that invisible 1. I can also do y to the 6th times y. Remember, y has that little invisible 1, and we get y to the 7th. Fantastic. Number 7. Let's pass out that negative 2 with our power to quotient rule. Excuse me. So we get x to the negative 14th over x to the negative 8th times x to the 2nd. I don't like it. Let's flip it. Also, you know what? I'm going to move this over on that side because I think that will look nicer. Oh, the magic of technology. That did not work. Ignore the magic of technology comment. I'm going to try it again. All right, now look at the magic of technology. Close. Close enough. All right, negative 14. So, x to the negative 14 on top means there should be an x to the positive 14 on the bottom. We got x to the negative 8th on the bottom, which means there should be x to the negative 8th on the top. And we're still multiplying by x squared. Notice how all of these are x's. We can find out the power of x now by combining the quotient rule and product rule. The quotient rule tells us subtract those exponents. So we're going to do 8 minus 14. The product rule states add the exponents when we're multiplying. So I'm also going to add the 2. Okay. Oops. Didn't mean to write the fraction line. We're not quite there yet. X. 8 minus 14 is negative 6 plus 2 is negative 4. We shouldn't have negative exponents. This is really 1 over x to the 4th. Fantastic. Number 8. Not too bad. We got some zeros. We got some negatives. Let's do some flipping. 7 does not have a negative exponent, so I'm just going to keep it 7. M to the power of negative 4 belongs at the bottom as m to the positive 4. N to the 0 is 1. So let's write times 1. 0 is neither negative nor positive. It stays where it's at. Okay, on the bottom, we have m to the 1st. That's positive, so it stays where it's at. We also have p to the negative 3rd. I don't like where I drew that. P to the negative 3rd, which means we need p to the positive 3rd on the top. And lastly here, we have q to the power of 0. Anything to the power of 0 is 1, so let's rewrite it as times 1. Let's simplify. On the top, I can do 7 times 1, which is 7. So that stays 7. P to the 3rd is the only p we have, so it just stays p to the 3rd. On the bottom, let's use the product rule. M to the fourth times M to the first is M to the fifth because we add the exponents. And anything times 1 is itself, so I could just leave that as M to the fifth. Although I'm going to rewrite it a little bit more centered so it looks nice. So it looks nice. If it lets me erase it, then I will absolutely do that. Are we lagging? Uh-oh, there we go. Beautiful. No, it's not. I lied. The 5 is not up enough. I need to make it better. Thanks for tolerating me. Okay. Those are our exponential properties. Let's continue. Oh, it's lagging. You guys see this? Uh-oh. Well, while it decides to unfreeze, okay. I was gonna ask how your day was, but I guess now we don't have. Oh, we do have time. I hope your day was a good day. I hope you're having a good study session right now. There we go. You come on, buddy. You could do it. There we go. Okay. So the next thing we went over is graphing exponential functions. Let's graph 4 to the power of x. We can do this in our calculators. So, in order to find out the y for x negative 2, we plug negative 2 into our exponent. Don't forget that when you're putting it in your calculator, you're using this little caret button to get the exponent. 4 to the power of negative 2 is 1 over 16. Then I'd put in 4 to the power of negative 1, 4 to the power of 0, 4 to the power of 1, and 4 to the power of 2. Now let's graph it. What we found are our x's and our y's, right? F of x is the same thing as y, so those are our points. First, we have negative 2 1/16. I'm going to do my best to guess where 1/16 is. I think it's right here. This is negative 1. For negative 1, we got 1/4, which is only a little bit taller than 1/16. Next, we have 0, 1. I start at 0, go up to 1. Then we have 1, 4. I go from 1 up to 4 and make a dot. Then I have 2, 16. I go to 2 and then up to 16. Let's draw our graph. Perfect. Number 10. Let's graph 4 times 1/3 to the power of x. We're going to do it the same exact way we just did, just by entering into our calculator the way we see it. 4 times 1/3 to the power of negative 2 is 36. 4 times 1/3 to the power of negative 1 is 12. 4 times 1/3 to the power of 0 is 4. 4 times 1/3 to the power of 1 is 4/3. And 4 times 1/3 to the power of 2 is 4/9. Let's graph it. Okay, negative 2, 36. So I'm going to go to negative 2 and then all the way up to 36. Well, then we got negative 1, 12. Start at negative 1, go up to 12. 0, 4. 1, 4 over 3. 4 over 3 is a 1.3, so it's right there-ish. And then 2 4/9. Oh man, I'm going to guess it's right here. Let's connect it. Oops, let's try that again. Almost. I'm going to give it one last shot. I tried. Okay, we're going to just pretend it went through that point. Okay? Okay. No! I gotta do it. The perfectionist in me. Even though I can't make it that pretty, I'm going to make it as perfect as I can. Come on, Gooman. fudge muffins. I was so close. I could do this. Thanks for your patience, friends. Okay, this is better, I think. Okay, whatever. It went through the lines, through the dots. Okay. Number 11, let's match the following exponential function to its graph. The way I like to do this is by looking at the y-intercepts. The y-intercept is always the number that we're multiplying the base by. So 3. So for number 11, the y-intercept should be 0, 3. Let's look. Letter A, oh, that looks like 0, 3. I'm going to check the other ones just in case there are 2 0, 3s. Letter B, nope. Letter C, no. Letter D, ooh, this one is also 0, 3. All right, let's think about it. This has a base larger than 1. So that means our graph should be increasing. Perfect. Letter A. Let's take a look at 12. First, let's identify its y-intercept. There it is, 0, 5. And now let's find the matching graph. Okay, this one works. Not letter B, not letter C. Letter D also is 0, 5. This has a number less than 1 as its base. That means our graph should be decreasing. Letter D. Let's write an exponential function for number 13 through 18. All right. So here, to write an exponential function, we need the y-intercept and the pattern. So the y-intercept in number 13 is 0, 2. So that's great. We found it. Now we need to find the pattern. In order to do so, we're going to do 0.4 divided by 2. 0.4 divided by 2 is 0.2, or maybe your calculator will give you 1/5. But that's all we need. So f of x equals 2 parentheses 0.2 to the power of x. Number 14. Oh, I don't see a y-intercept. That's okay, because I can figure it out. The y-intercept, if we had it, would be up here with the 0. So let's find the pattern and go backwards on the pattern. So I'm going to do 324 divided by 36. Pretty sure that's 9, but I gotta double check. Sure is. Good job, me. The pattern is 9. So to go backwards, to find out what number was before 36, what I'm going to do is do 36 divided by 9, which is 4. So f of x equals 4 times 9 to the power of x. Ooh, you know what? I want to do 18 next because it's also a table. I want to do the tables first. All right. Number 18 is similar, though, to the one we just did. We are so close to that y-intercept. We need the 0 right here. So let's find the pattern, and then we could follow the pattern because it's coming up next. We don't have to go backwards. All right, so to find the pattern, I'm going to do 50 divided by 250. So 50 divided by 250 is 1/5. Yeah, it's 1/5. Perfect. So in order to find the next number, we're going to do 50 times 1/5, which is 10. We have the starting point, the y-intercept, and we have our pattern. Let's write our function. F of x. Almost. There we go. F of x equals 10 times 1/5 to the power of x. Now let's do the graphs. The graphs are very similar, except we just pick 2 points and go from there. I always like to pick the y-intercept. That's one of the best ones to pick because we need it. Creating a little table, 0, 6. And then I'm going to use the next available perfect point, which is right here, 1, 3. Let's find the pattern by doing 3 divided by 6, which is 1/2. So for number 15, f of x equals 6 times 1/2 to the power of x. And just highlighting it so you see where I got everything from. Number 16, let's do the same. Here we have 2 and 8. Let's do a little table. 0, 2, 1, 8. 8 divided by 2 is 4. So our function is 2 times 4 to the power of x. All right, last one, number 17. Oh, perfect. These points are already labeled for us. And on top of that, I have my y-intercept, which is 5. Perfect. Oh, wait, I'm going to write a little table anyways. I like the way it looks better. All right, and I'm going to find 2.5. Okay, let's find the pattern by doing 2.5 divided by 1.25. 2.5 divided by 1.25 is 2. Cool. We have everything we need. F of x equals 5 times 2 to the power of x. Whoops, I got the colors wrong. That was crazy. I don't think I've ever done that. That was very new. There we go. Okay, that's it. If you have any questions, please let me or whoever is helping you with this know. Otherwise, have a wonderful rest of whatever day it is for you. Bye!